We come to another session of financial mathematics. This is part 3 of the 4 videos. Very important for the grade 12 learners. Watch and learn. Investments or loans, annuities. Annuities is a series of equal payment. It can be investment or a loan repayment at regular intervals. That is meant by annuity. We have future value annuity and present value annuity. Let us learn future value annuity now. We have a formula for that. The word itself, future. The investment is done and the money will be available only in future after a certain number of time. So here is the beautiful formula. It's available on your formula sheet. You don't have to memorize it. But you must know that you are doing a calculation for a future annuity. So F equal to X times 1 plus I to the power N minus 1. What is X? X is the equal payment. It can be made monthly, half yearly, or even yearly. I is the interest rate and N the number of payment. Suppose that 1,000 is deposited into a bank account 1 month later. A further 1,000 is also deposited. Again, another 1,000 after 1 month. So we have 3 payments. The interest rate is 6% per annum, compounded monthly. How much will have been saved after 2 months? But we can see that, look at the timeline, we have already paid 3 times. 2 months, but 3 payments are done. So that is very important. You must look at the payment periods. Now 2 months, saving period, but 3 payments, including the time 0, the very first day. So we use the formula and substitute the values very carefully. Here X is 1,000, N is 3, not 2. And the I is 0,06 over 12 minus 1. Divided by I. Now we use the calculator. Good people, the calculator is always helping us, but it's also very important that we use it very, very seriously. We have to know that if you see 2 brackets, bracket, again bracket, that should be punched into the calculator. Otherwise, you are going to get a wrong answer. So using the calculator is also very important. You save time, you get the mark, but you have to practice a lot of questions on the calculator. Suppose that 1,500 is invested every month, starting immediately for a period of 12 months. So you underline all the important numbers so that we can pick those things very quickly. So here it is 1,500, 18% compounded monthly, period of 12 months. So look at that. Immediate payment, 1,500. So although it is 12 months, the payment, how many payments? 13 payments. Because 1,500 is invested every month and starting immediately. So we use the formula. N is 13 here. and we use the calculator and get the answer. Now, if the first payment is not made immediately, what will be the value of n? It's not going to be 13. It will be only 12 if you pay after 1 month. So the calculation is done using n equal to 12. Look at the difference in the investment values between the first one and the second one. So that is the difference and the importance of the value of n. Another question, Glover decided to start saving money for a period of 8 years. Underline that. And starting on 31st December 2009, at the end of January, he's paying only in 1 month's time, after 1 month. Very important. No payment immediately. Interest rate is 10% compounded monthly. And then we are going to calculate 8 year. So we substitute 8 times 12, 96 here. N is 96. So we use the calculator and get the answer. Practice the calculator. Double check. Maria deposits 400, 14% per annum compounded half yearly. Paying 400, then 6 months later, not the next month, after 6 months, she continues after every 6 months paying 400. How many years? 9 years. Now, what is the interest rate? 14% compounded half yearly. So we must notice all those important values there. Look at the value of n here. Immediate payment. 9 years. 9 years half yearly payment. 9 times 2. 9 times 2 is 18. Plus 1 because of the immediate payment. Making n is 19. Substitute into the formula. Use your calculator. Nancy has just turned 20 years old and has a dream of saving 8 million by the time she reaches age of 50. So it is total 30 years saving. 18% per annum compounded monthly. Her first payment starts on her 20th birthday. 20th birthday. And last payment is made 50th birthday. So 20 to 50, 30 years, 18%. Here is a timeline to show the details. We have a beautiful timeline here to understand better what is our question here. How much will she pay each month? We do not know how much. So we assume that it is X. So we are going to solve for X. Now we have the formula of F. Now from there we make X as the subject. That is the easiest way. You solve for X. Make X as the subject of the equation. And then we get the values are available now. N is 360 plus 1 because she is paying on the 20th birthday. So 361, N is 361. Substitute into the formula. What is F? 8 million. And the rate is 18% compounded monthly. Just write the numbers very carefully and use the calculator. You get the answer. So good people, again I am insisting you to check again your final answer. 3 questions to practice. Practice in the sense you must work out this question and then double check your answer with the answer. Here is the answer. The answer, until you get the answer, you must practice. That is the method of learning these topics. You may not get the proper and correct answer in the beginning. You try again. These are the answers. I'm giving you the answers there. Use the calculator properly. Moving on to present value annuity. What is present value? Present. The money is available at present. So the same thing, but we have to repay the loan. You see, the present value is there. You take a loan, you repay it to the bank. So the present value is available, then you repay. Okay, for example, here is 1,000 rand is paid every month. What was the loan? That is a question. Suppose the loan is repaid by means of 1,000 to 1 month after. So in this formula, we have a beautiful formula here. Now, substituting the number, it is power minus n. So it is minus 2. Okay, two payments. Now remember that there should be a gap from the day of the loan availability and payment. So after 1 month you start paying. So then we can use this formula and we substitute into the formula and use the calculator. Manionga takes loan to purchase a car, 5 years loan, monthly payment 5,000. 1 month after, look at that, interest rate 24%. Calculate the purchase price of his new car, meaning the loan. So we substitute 5 years, okay, monthly, 5 times 12 is 60, but remember that it is minus 60, very important. So you can simplify and use the calculator. Again, Patricia takes out a 20-year loan of 100,000. She repays the loan by means of equal monthly payments starting 3 months after. Look at that, not 1 month after. So that is very important. On this question, what happens? It is 20 times 12 is 240. But she fails to pay after 1 month, no payment. Another month, no payment. Only after 3 months. So 2 payments missing there. So the number of payments is 238 only. So that is important. And then what happens to that 2 months? She has to pay interest on the loan for 2 months extra. So we calculate the compound interest for that for 2 months using the formula 1 plus 0.18 over 12 to the power 12. We get 103,022, not 100,000 now. So that is the P we are going to use for this question. Remember, learn these type of questions. So we are using that amount. 103,022,50. Substitute into the formula. Use the calculator. Malibongwe takes another loan, 24% for 5 years. And what is the question? Calculate the monthly payment. Calculating X. So Malibongwe deposit 10,000. What we do? That 10,000 should be subtracted from the loan. So we subtract 10,000, we get 163,804,43. That's the only difference in this question. So read the question very carefully and substitute the right number. Use the calculator. That's all. Practice questions, another 3 questions. You must practice them. Check the answer. You must try until you get the answer. Use the calculator. And that is the end of part 3. Hope you will practice. More questions are available on the metric paper. You work out as many questions as possible on annuities. Okay? Good luck.